Assalamu alaikum and welcome to the channel. Before we dive into the core of Python programming, make sure to hit that subscribe button and turn on notifications so you don't miss any part of this complete Python series. Today we are exploring the most fundamental concept in any programming language, variables. Whether you're building a simple calculator or a complex AI model, everything starts with how we store and manage data. Think of a variable as a labeled container in your computer's memory. In this session we'll break down how Python handles these boxes, the strict rules for naming them, and how Python's dynamic nature makes coding faster and more intuitive. Let's get started. A variable is like a container. To understand variables better, think of them as labeled boxes or containers. In programming we deal with a lot of information and variables help us keep that data organized and accessible. Think of a variable as a labeled box that stores data. The process is very straightforward. You give the box a name, you put a value inside it, and Python remembers that relationship for you. Let's look at the first example, x equals 10. In this line of code, we have created a box and named it x. We then place the number 10 inside it. Now, whenever we mention x in our program, Python knows we are referring to the value 10. In our second example, we have name equals Ali. Here, the box is named name, and the value inside is the text Ali. By using these labels, you don't have to remember where the data is stored in the computer's memory, you only need to remember the name you gave to the box. This simple label and store system is the foundation of how Python manages information. Just remember, the name is your label and the data is your content. How variables work in memory. Now that we know variables are like containers, let's go a level deeper and see what actually happens inside your computer's memory when you write code. When you type a simple command like x equals 10, Python performs two crucial steps behind the scenes. Step 1 is storing the value. First, Python finds an empty spot in your computer's memory and stores the value 10 right there. At this point, the value exists, but we don't have a way to easily grab it yet. Step 2 is creating the label. To make that value useful, Python takes the name you chose, in this case, x, and turns it into a label that points directly to that specific memory location. The most important thing to remember here is that a variable is actually a reference. It is a pointer to an object in memory, not the value itself. Think of it like a shortcut on your computer desktop. The shortcut isn't the file, but it knows exactly where the file is stored so you can open it anytime. Data types in Python. Now that we understand how variables store information, let's talk about data types. In Python, every piece of data belongs to a specific category. This type is crucial because it tells Python exactly how to handle and process that information. Let's look at the four most common types you will use. First, we have the integer or int. These are whole numbers without any decimals. They can be positive like a equals 5 or negative like b equals minus 10. Whenever you're counting items or working with whole values, you're using an integer. Second is the float. Floats are used for decimal numbers or floating point numbers. If you need precision, for example the value of pi, x equals 3.14, or a negative coordinate like y equals minus 2.5, you use a float. Third, we have the string or str. This is the data type for text. Whether it's a single letter or a whole sentence, we wrap it in quotes to tell Python it's text. For example, name equals Ali. Remember, anything inside quotes is treated as a string by Python. Finally, we have the Boolean or bool. This is the simplest data type because it only has two possible values, true or false. We use these constantly for logic and decision making, such as checking a condition like is_student equals true. Understanding these categories is the first step toward writing real programs, as Python performs different operations based on the data type you choose. Collection data types. Now that we've seen how to write the code, let's summarize the collection data types we just covered. These are essential for handling groups of data efficiently. We have the list. Think of this as your most flexible option. It stores ordered, changeable values, meaning you can update or modify the items inside the square brackets whenever you need. Next is the tuple. It looks similar to a list, but notice the lock icon. It stores ordered, unchangeable values. Once you define a tuple using parentheses, those values are set in stone for the rest of your program. Then we have the dictionary or dict. This is like a filing cabinet where every piece of information has a specific label. It stores key-value pairs, making it incredibly easy to look up a specific value, like finding the age associated with a name. Finally, we have the set. Sets are specialized for storing unique values only. As you can see, there are no duplicates allowed here. If you try to add the same number twice, Python will simply ignore the second one. Each of these collections has a specific purpose, and choosing the right one will make your Python code much more organized and powerful. Now, let's jump into the code editor and see these data types in action. I'll show you exactly how to write and execute them. First, let's look at integers, which are whole numbers. I'll start by adding a comment, #integer. Now, let's define a variable named age and set it equal to 20. To see this value in our console, I'll type print, age. Alright, the code is ready, let's run this. As you can see in the output, it shows 20. Simple and clean. Next, let's look at floats. Floats are used whenever we need to represent a number with a decimal point. I'll add a comment here, #float. Now, let's create a variable called height and assign it the value 5.9. To output this to the screen, I'll type print height. Okay, let's run this. There we go. The console now displays 5.9. Moving on with our code, let's look at how we handle text and logic in Python. First, we have the string data type. I'll start by adding the comment, #string. Now, let's create a variable called name and assign it the text value, Ali. To display this name, I'll write print, name. Alright, the code is ready, let's run this. As you can see, the output shows, Ali. Since we used quotes, Python knows this is text data. Next, let's look at the Boolean data type, which is used for true or false logic. I'll add the comment, #bool. Let's define a variable named is_student and set it to true. Notice that true starts with a capital letter in Python. Now let's type print is_student. Okay, let's run this. And there it is, the console outputs true. Booleans are incredibly powerful for making decisions in your code, like checking if a user is logged in or if a task is completed. Now, let's explore how Python handles collections of data. First, we have the list. I'll start with the comment, #list. Lists are great because they allow us to store multiple items in a single variable using square brackets. Let's create a variable called number and set it to 1, 2, 3. To see our collection, I'll type print, number. Alright, the code is ready, let's run this. Perfect. The output shows our entire list of numbers. Remember, lists are flexible. You can add or change items in them later. Next, let's look at the tuple. I'll add the comment, #tuple. Tuples are similar to lists, but we use parentheses, and they are immutable, which means once you create them, they cannot be changed. Let's define data and set it to 1, 1, 1. Now I'll type print, data. Okay, let's run this. There we go. The console displays our tuple. You would use a tuple when you want to make sure your data stays exactly the same throughout your program. Now, let's look at two more powerful ways to organize data, dictionaries and sets. First, we have the dictionary. I'll start with the comment, #dictionary. Dictionaries are unique because they store data in key-value pairs, almost like a real-life dictionary or a contact list. Let's create a variable called person and set it to name, Ali, age, 20. Here, name is the key and Ali is the value. To see this record, I'll type print, person. Alright, the code is ready, let's run this. Excellent. You can see the whole mapping in the output. This is perfect for representing complex objects. Next, we have the set. I'll add the comment, #set. Sets are collections that are unordered and, most importantly, they do not allow duplicate values. Let's define uni and set it to 1, 2, 3, using curly braces. Now I'll type print uni. Okay, let's run this. And there it is. The console shows our unique collection. If I had tried to put another 1 in there, Python would have automatically ignored it, keeping the collection distinct. Dynamic typing, Python's superpower. Now let's talk about what makes Python truly special, dynamic typing. In many other programming languages, you have to tell the computer exactly what kind of data a variable will hold before you use it. But in Python, you don't need to declare a type at all. Python figures out the data type automatically. It's like a chameleon that changes its color to match its surroundings. Let's look at the example on the screen. First, it's an int. When we write x equals 10, Python looks at the value and immediately sees it as an integer. But here is the superpower, then it becomes a string. If we later write x equals hello, Python doesn't complain. It simply updates the variable and now x is a string. This is the essence of dynamic typing. The type is decided at runtime by Python, not by you. This gives you incredible flexibility and allows you to write code much faster without worrying about rigid data rules. It's one of the main reasons why Python is so beginner-friendly and powerful. Checking a variable's type. Since Python handles data types automatically, you might sometimes wonder, what exactly is inside this variable right now? That is where the type function comes in. The type function is a built-in tool that tells you exactly what Python thinks your variable is. This is incredibly helpful for debugging your code or just learning how Python works behind the scenes. Let's look at the code example. If we have x equals 10 and we want to verify its type, we simply write print type x. Python will look at the value 10 and output class int, confirming it's an integer. Similarly, if we have name equals Ali, we can check it by writing print type name. Since the value is wrapped in quotes, Python will output class str, identifying it as a string. My quick tip for you, use the type function often while you are learning. It's like having an X-ray vision tool for your variables, ensuring your data is exactly what you expect it to be. To wrap up our deep dive into variables, let's look at how Python handles assignments between variables. Suppose we write the code a equals 5. As we discussed earlier, Python creates the value 5 in memory and points the label a toward it. But look what happens when we write b equals a. Most people think Python creates a second copy of the number 5, but that's not what happens. Instead, Python is efficient. It simply takes the new label b and points it to the exact same memory location where the 5 already exists. As you can see in the diagram, both a and b are now shared references. They are two different labels pointing to the same single object in memory. Understanding this is vital because it explains how Python saves memory and how it behaves when you start working with more complex data like lists. Just remember, in Python, variables are labels and multiple labels can point to the same value. All 8 data types at a glance. To wrap up our lesson on data types, let's take a final look at this summary. This is your ultimate cheat sheet for deciding which data type to use in your projects. We've covered the core 4. Integers for whole numbers, floats for decimals, strings for any kind of text, and booleans for those essential true or false logic flags. Then we explored the collections. Use a list when you need an ordered group that you can change later, or a tuple if that group needs to stay fixed. Use a dictionary when your data needs a name or a label to keep it organized, and a set when you only care about unique items and want to avoid any duplicates. Choosing the right type is like choosing the right tool for a job. If you have numbers, go for int or float. If you have names or messages, use str. For simple yes or no answers, bool is your best friend. For complex data management, pick the collection that fits your needs. Mastering these 8 types gives you the foundation to build almost anything in Python. Keep this guide handy as you start writing your own scripts. Key takeaways. To conclude our session, let's review the key takeaways from today's lesson. Variable equals named container. Remember that a variable is simply a stores data and gives it a specific name that you can refer back to whenever you need it in your code. Variables reference memory. It is important to keep in mind that a variable is just a label pointing to a location in your computer's memory. It is not the actual value itself. 8 built-in data types. We have explored the primary tools in your Python toolkit: int, float, str, bool, list, tuple, dict, and set. Each one serves a unique purpose depending on the kind of information you are working with. Python uses dynamic typing. Finally, don't forget Python's superpower. Data types are decided automatically for you. If you ever feel confused about what a variable is, just use the type function to check it anytime. Great job getting through the basics. You now have a solid understanding of how Python manages and stores information. Happy coding! That brings us to the end of our deep dive into Python variables and data types. If you found this explanation helpful, don't forget to hit the like button and share this video with anyone who is starting their coding journey. Make sure to subscribe for more Python tutorials, and I'll see you in the next one.